Hello everyone. As you know, I will not be in the school next week, so I am making this video to explain what we need to do during uh, this week. You will have a lot to do basically in the lab. We are going to move to the real robots. So the first robot we will start is with this YUMMI robot, YUMMI 14,000. Let's get to know it, and I'll explain how you can program it, how you can let me see here. Yeah, task 9 is this one. How you how the robot Yumi works, how to program it, how we can use Flex Pendant to make and run the program, how to jog, uh, how to jog the robot in different coordinate systems, how to load the program to the real robot. Let's start with the see how the robot program this robot works. Yumi 40,000. This is basically two robots that is being controlled by one controller. So two arms, one controller. We have to I just added this robot from here. It's empty station. Then you add this RRB 14,000. So let's go to the. I want to add smart grippers. Smart grippers, if you haven't downloaded before, they are like this downloadable. But I want to add this one, smart gripper. Yes, the first one. Here you can decide camera, fingers. On the right hand we have servo, one vacuum cup, fingers. Yes. Let's and how you add it to the robot. You can see there's two hands, right and left. I want to add the smart gripper to the right hand. Drag and drop on the right hand. Yes, that's done. Let me add another smart gripper. And this one has camera, one cup, and fingers. So let's add that. Yeah, this has the camera in it and on the left hand. Yes, update the position. So two, you have basically two robots. How to program it will be, this is ready. We want to make a program that moves between 2 points. And I want to use the right hand. The left hand, let it be for now. On the right hand, let's go here. Let's create this is our station that has the hands. Yes, default. Let's add the no, controller from the layout. We make next. We are having an error here. Says the robot version is newer than the version officially supported by the release of the Robot Studio. This may result in unexpected. Let's go to the other version, 6.15. If you don't have the 6.15, you can download it from the add-ins. So you can just select the version and add it. So next. Yes, everything's okay. Everything that the way that it is, finish. Let the controller be built, and then I will start making the program. We can make the same way that like creating the program can be the same way as like the other robots, that I can just like teach the positions, move it using this move tool. But this is a bit different in a way that we have two hands. We have to select which hand we want to teach the hand. So we have the controller right now. You can see there's two arms. Right now the left arm is active. This is shown in bold. we have to select this right hand and set as active. So this one is active now. Let's start teaching the targets. Right now I want this point to be the home position, but difference is that here we have like one and two different tools in this hand. There's a vacuum cup and a servo gripper. So here you can see that selected right hand, work object 0, vacuum cup 1. We don't want vacuum cup 1, we want servo. So when we are teaching the home position, this information will be saved to the data of that position. So let's teach this here, teach target. This is gonna be my home position. Yes, home. All the targets that I will define will be this. Let it be home position. I'm not teaching the other positions yet. So I will teach them using the Flex Pendant. Like I could use this for the movement. Like I can make this gripper, this one, and move. Like I can move it like this, and if I press teach target, the new positions will be here. You can see target 10, and then I move it here, teach target, target 20, and I can create my program. But I don't want to do that. I want to delete them, and I'm going to use Flex Pendant for this. So we have done this, how to jog the robot. We want to learn this right now, how to jog the robot in different coordinate systems. So I guess you know how the YUMMI works now. So let's go to this one. And for that, let's download this. Let's go to the controller. We open the Flex Pendant. Right now, this is IRC5 is active. For this, if you use the correct controller version, this will be on. And if you don't have this active, you can go to the add-ins in the gallery. This one, Flex Pendant A6 TPU, or you can add this one, and hopefully it will activate your control, your Flex Pendant here. So I want it to come right now. So let's explain this again, because the Flex Pendant for this also is a little different menu than the usual robots. As you can see up here, there's two robots, one left arm and right arm. There is some menu here that you can see. This is the menu. If you click on here, you will have this option here. You click on this control of the robot. You want it to be auto mode or manual mode. This menu is exactly like what you have on the real Flex Pendant near the robot in the lab, robot lab, B212. So this is how right now is selected on auto mode. I select it on manual mode, and I can turn the motor off or on. Yeah, now motor is on, it's manual mode. I just want to jog the robot. So I go here also, two robots. Which robot you want to jog? Double click on that. This goes to the right, but now I want to go to right hand. This picture shows which coordinate and with which tool. Right now, this is tool 0. I wonder why the tool has not been configured on this. That's okay, we use tool 0. Tool 0 means will be the flange, the caliper that is on there. I show details. Let's move the robot. Like if you want to turn specific joints, you will select one of 1, 2, 3, 1, 2, 3, 4, 5, 6. 4 is I think somewhere here. 5 and 6 is this one. The flange itself will turn. And there's 7 also. This robot is different than the other robots. This has 7 joints in each arm. The seventh joint is, I think, this one. Let's see. This is the seventh is active right now. I want to turn with this. You will see which arm is gonna work. That joint that is turning, that one is the seventh joint. But important thing is when you are trying to do the jogging a real robot, make the speed here. Here, this is speed should not be 100% when you're jogging the real robot. You go here, like show details, make the speed like 50, 30. 30 would be perfect because you're sure that you don't break the robot arm with some sudden movement. Right now it's simulation. I want everything to go fast. So 100%. And now this is the joint movements. For example, let's see the joints 1, 2, 3. Joint 1 is this one. If I press this up, oh no, there is collision there. I think joint 2 is right now is turning. Acknowledge that, and yeah, it went against against the frame before. Joint 1 should, this is like turning the joystick, which direction you want to press the joystick. Like you can press it in 8 different directions and also turn it. Turning it also is turning the one joint. This is joint number 3. Joint number 1 is this joint. You see this one is turning. So this is showing how you can jog the robot in joint coordinates based on each joint. But if you use this, for example, the base coordinate and on the work object like XYZ, you can choose the world coordinate and XYZ, base coordinate XYZ, tool coordinate, and XYZ work object coordinate, user defined work object coordinate. So we will generally use this one or this one. If we want to go near some specific tool with this one, you should actually check all of these combinations. If you have work object, you can test this one also to understand what goes on. This and these are the same because their origin is the same in the beginning. So I want to go in X direction, for example. This is X, Y, and Z. Like that, I select world coordinate and I want to move on the direction of the XYZ axis. So I press this one. I've selected the type. Now with the joystick, I can move it up and down. This is X plus. If I twist the joystick, it will go up, and the other way around goes down. So now, like this one is also important. If you want to work with the TCP and tool coordinate, for example, you want to like you have a like TCP tool is at some point you want to turn the robot around this TCP. So TCP will be stuck here, not moving, and you can turn the robot around it. Let's try this one. You will see, for example, now I am, yeah, it's not recognizing this tool here. It's recognizing the this part, like the flange. So, but if you have the tool recognize it. Here I don't have the servo for some reason. So that's okay. That's okay. I'll let it be. If it was servo, it would be keeping this TCP here. And now let's go to the how to make the program. We will make a program that robot moves from P1 to P2 and goes back. I will show it quickly here. So with jogging, you learned how to do the jogging, program editor, and program data. This is for modifying the like the parameters in the program. Program editor is for creating a program. Like after selecting program editor, you should select again which robot you want. I want the robot like the right hand. There's no program here. It's like uh, it has the ready function, main function here. I have to add your code here. It's saying, and there's a menu here. Add instruction, move J. I want to use like move J type and move L type right now. Move C is here also if you want to write like if condition here, return, procall, reset. This kind of these are all the functions that you can go next. There's many more like yep, that is a lot of functions, but we want to work with MoveJ. I want the robot to come to this position that is right now. So I will add instruction MoveJ. So it asks, do you want to be above or below? Now you can see the robot has with this menus you have to go like up and down to see your entire program. So this is how the program is added. It doesn't have a name, so like you see, it doesn't have a name right now. It is this star. If I want to have, for example, 3 points, I will add here P10, okay, new P20, okay, and I want to add a P home also. Not P, just home 1, let's say. Home 1. I am creating it here. And so let's save it. So I created 3 names. They don't have any data in it, but here I can add the move J home. So let's say this is home 1 and it becomes okay. Okay, so move J home, modify position. So I have this home 1 in there. I have to like click on the modify position. The operation cannot be undone. And this is saved now. Home 1 is this point. Uh, let's move the robot. You see in here I have the program editor. I have this like program line that is here. Now I want to add another line here. Next one. I would let's first move the robot to new position on the X, Y. I select from here, move the robot here. Let's move forward a little. Mm, okay, I put the hand here. This is P10 and 20. I want to be there. So move J. It made home 11. It created this name for it, but I want to make it P10, modify position, modify. And the next, for example, I want to do a wait time here. Let's go wait time. And here I want the expression select here on this 1, 2, 3. 1 second. Okay. Okay. Wait time 1 is added. After this, I want to go to the P20 that I have the name for right now. Add instruction. Let's move the robot first. So this is the P20. After this, I want to add this move J to P30. But P30 I don't want. I want the name to be P20. Okay, and this P20 modify position modify. Now I have I want to go to this line back again. This menu edit is for this copy, and then I come here, paste. So easy. These tools for editing the program is here also. You can just uh, get to know them. Try to create like one simple position by moving the robot around. And now my program is ready. Moves to P home, P10, waits here, P20. Let's add this wait time here also. Copy, select on this, and after this I want to bring this wait time. So I have this program ready, and I have to now compile it. For compiling, we say debug pp to main. Are you sure you want to move to the pp? Yes. Now program pointer is here waiting for me to start like debugging the program. I can go here. The program is added to the main. Now let's press step by step. At least one task is missing, a robot program pointer. Program pointer is here. Why it is? Okay, we say debug pp2 routine. Okay. Let's see what is going on. Why? I don't understand what the problem. It's not opening. You can see if you go here on this one, you can see the left hand is a normal, but the right hand is in some kind of stop mode. That's why it's not running the program. But it had to run this program by pressing this. The robot should start moving there. But it's okay. Let's save this program right now. We go to here, the right hand, show module, and we can see this is this one. We want to file, save the program. Yeah, robot R, save the program as, for example, program 1, we put, and okay. So on the right hand robot, we have a program that is saved. On the left hand, we don't have any program. Let me create a program in this one quickly, new program. This one will work for sure. So because you can see here, this one is in the normal mode. This one has, I have to check why it is stopped. So let's add instruction to here, move J. I will add, just move it, and then now let's go to the thing. I want to move the left robot. There's some kind of problem in the here should be the servo tool existing and vacuum cup also, but okay, we just want to move it. The left arm. Is it this one? We want to move it there. And then the home position was this one that added. Now move J below. This is the second position. And I would move it up. And I teach this again. Move J. So I have three positions. Let's make this one home 1 and 2. I click on this, the 2 point. New, let's make home. Okay, then new E1. Okay, new E2. Okay, so right now this is P2. Yes, let it be P2. Okay, modify position. I want to make sure this is recorded. Then this one I would put instead P1. Okay, and this one let's put home for it, just the names. And I will, okay, P2, P1, home, doesn't matter. Now debug to main. Now we have the program pointers here. Yes, rope targets are made in this one. Let's press the start. Now, yeah, this is how it should work. P2 is this one. P1. Oh, the other one is working as well. Strange. Now there's both of them moving every time that I press play. The next point. So this robot doesn't have the points hitched to it. So let's move the robot and then modify the position. I move it forward, modify position, and then home. I will lift it up, and that I wanna teach it modify position. So debug pp to main starts from there. Let me deactivate the right hand. Right hand is now deactivated. I just want to work with the left hand. And I just debug pp to main. That is left hand. Now it is going to the P2. Next P1. And home is up. Play will run the program constantly. And I can activate the second robot also. Let me stop that. Activate this robot also. And if I put play, both programs will be playing. So that's how you can work with this Flex Pendant, and that's basically easily possible. During this week, anytime that you have time, please go to the lab and like make a video of you running this and upload it to the task 9. Task 9 is very important because it will show how you are able to write the program and test it. So, okay, let's stop this one. Now the second part, let's see what we did. How to program it. We did how we can use Flex Pendant to make and run the program. It is how to load the program to the real controller and save it. I will explain this one also now. This is in Moodle course. We have I would suggest you to take a look at this ABB Flex Pendant manual and how to connect to ABB robot. These two files I have added, you can take a look. Then this is the Flex Pendant manual. It would be very good if you just take a look in general to understand what it is. And if we are going to connect to the robot, we the only way that we can connect to the robot is through the service port with the like Ethernet cable that in the lab we have. So you can connect the laptop to uh, the service port of the controller, and then you do as this one shows here. This is a document for another type of robot, but like it is the same process for ours also. So you have the model, this parts of or creating the model, the program will be ready, and then there is this stage. This is, for example, the robot. The positions are teached here. Synchronizing to rapid, you know how it works. Then you have the project view, the controller. You see the controller. This is the simulated controller, like virtual controller. Now you should at the end check the program in simulation and short that you don't have to add the controller to the project. Here is for the other school, but if you just connect with Ethernet to the service port of the robot and the IP address, like you will not have this option there. You let me show here. Okay, I have the program running. I want to connect it to the real robot and copy my like download my program to it. You just go here, controllers, add controller, connect to controller. If you press this, here it will give you an IP. It will ask you for the IP and then locate and you find the controller. If you have connected correctly, it will connect to the robot and you say OK, and it will create this kind of controller for you. So this is the station. Yeah. For the username, you just put login as default user. You don't need to enter anything. After it created, you will have this kind of view. So you have the robot. This is the controller of the real robot, and this is the simulation control station. And you will have this like that. This is the station, and this part is the controller. So it has module 1 and our simulation had a module 1 also. This code we have to copy it and paste it in this. And this is how we are copying the program to the controller of the ABB robot. As you can see, you will have different menu. And in order to be able to like overwrite the program that is already existing on the controller, you need to request write access from the computer, and then on the teach pendant it will like I give you the option to grant it or reject it, and you grant from the teach pendant screen, and then you will be able to do any modification here. After your work is done, you have to release the work write access from here. So after deleting the positions and programs on the rapid controller, this is the real robot. Copy and paste your program from virtual controller to this one and release the write access. Yeah, this is the station controller and the real controller. From here, copy and paste on this one. Yes, this is the real like IP address that you can see here. Also, this is not the IP address of our school robot, but that I will tell where you can find it. Then, yeah, when you have the new program on the controller, you can just like you can just apply the changes on the rapid, and you will have the program there. After you have done it, you release the right axis. Do you want to apply changes? Yeah, that's now you can go to the teach pendant there. From the main menu, open the program editor, click on the position and teach them. All the positions you have to modify again. You move the robot to the correct position and press modify position. Debug the program from PP to main. Go over the program by pressing the next button line by line. After program is finished, if there was no problem, you can press apply, press play and play button to run full program. So this is how the logic works. Now you can go back to your computer and modify the code in a way that like uses only a corner position. This was a task for the robot in another school. So, but it's a document that shows how these are the screenshots from the book that shows how you can connect to the like controller and download your program to there. Mm. So let's go over this again. After the connection, you will have two controllers here basically. In the controllers, you will have this controller and then the real controller here. And on each of them, there's a rapid. You see here, there's a rapid. Like, let's say we have this program, for example, here on the left and the right hand. We click on this. On the right hand, we have this code. We copied and pasted. We copied and pasted on the real controller rapid. We want to teach the teach these positions again to the robot. We go here. This program is the left hand, so I would go here and then save the program as no name program. Left hand program. So this is the left hand program. I save it. Now I go to the right hand. I will open it to see what is open. What is the program? This is the right hand program. Now I want to teach these positions home 10, 20. I have 3 points in the program. I want to teach those to that. So let me go to the right now I think it is in automatic mode. Manual mode should be motor on. We can jog the right hand. We want to jog the right hand in this coordinate. So let me go to the simulation here. I want to modify these positions. You see P10, 20. I want to modify them. The home position. Let's make this place the home position. If I go right now here, this is the home position. I want to move it a bit forward. Yes, I want the home position to be here. So I have selected this. I write modify position. Yes, now home position is here. Now we want to go to some new position. So this was the home position. I am moving here. I want here to be my P10 position, modify position, yes, and then let's move it up and I will teach the higher here to be the P20. So I have P home, I don't know why P10 didn't teach. So P20, I make sure cannot be undone, okay, that's fine. So now I teach home 10, 20. Let's go over the program again. We can deactivate the other arm from here. I want the left arm not to work. So program is changed. So debug BP to main. Everything okay. Now the home position. The robot should move. Yes. Now robot moves to home position. Then I press the next position 10 that came here. And I have to press 3 times on button. That's how it works now. You see, home, E10, 20. And I have deactivated the left arm, so if I want to activate it, I have to just stop this. Then I can activate it. And if I would play, all of them will work together. So I hope you can watch this video again and again and take some notes for yourself and go on the robot and safely start working with the robot. Again, when you're doing the jog, speed less. You can make it 30. I would suggest 30 because it will give you time to react in case robot is going against the frame or the body. Something is like abnormal. You can just notice and stop the robot. So that's all that I wanted to say. I hope everybody can like work with this and learn it because it's very important. You don't want to work only in simulation. You want to work on with the real robot. So okay, thanks for the attention and see you soon.